Welcome back to Algebra 2, Chapter 2, Section 3 in this book. And we're talking about quick graphs of linear equations. Now, everything we've done so far and everything we're going to do for a few more sections is review. So if this is too fast, go back and watch the slower videos in Algebra 1. If those are too fast, I cover the same topics in pre-algebra. So you can hear different presentations, different songs, different dances. Alright, so we're going to talk about the quick graphs of linear equations. That means no exponents. I'm looking for my marker here. No exponents. We can tell that this would have no exponents like in this equation here. And if it has no exponents or x or y, then it's a line. And so if you have y all by itself, it's called slope-intercept form, and by tradition, x's go before the bare numbers. The coefficient that goes with x is the slope. The bare number is the y-intercept. We already talked about why is slope m? We don't know. Great mystery. I think the reason why the y-intercept is b because it's a bare number. B for bare number. You think? Maybe? I don't know. Alright, so how do you do a quick graph of this? What you do is you go to the y-intercept and you put a dot. So I go to -1 on the y and I put a dot. And then I look at the slope. And the slope is rise over run, or you can think of it as up over over. So my slope is 3. What about the denominator? It's an understood 1. So I go up 3, 1, 2, 3, over 1, put a dot, whoop-de-doo. There's my line. Now remember I told you I will not take graphs unless they have an if-then chart. So we go back and fake it and make the if-then chart. So when x is 0, y is -1. And when x is 1, y is 2. Perfectly good graph. That'll get you credit in college. Okay, here's another one. Oh, that one was supposed to be purple and this one was supposed to be green. We'll change it all up and make this one red. Okay, here's this one. So we go to -2 and put a dot. And this one we go up 3, 1, 2, 3, and over 4. 1, 2, 3, 4. 1, 2, 3, 4. And put a dot. There's that line. If it was a system of linear equations, we'd want to know where they connected. Okay, now let's do our thing. So if x equals 0, y is -2. If x equals 4, y is 2. We went up 2 because we go up 3, 1, 2. Oh no, y is 1. There, y is just 1. I did it right, I said it wrong. 1, 2, 3, 1. It's a whole lot easier to do, which you need to do. If you use real graph paper and a ruler and colored pencils, I want them pretty. Okay, so that's what you do if it's no exponents and y is by itself. But what about if it's in standard form? Remember, standard form is a coefficient with x, then a coefficient with y, and a bare number over here. And then you do what I call it's actually called using intercepts, but I call it the cheater pants method, and I used to not teach it in Algebra 1 because I figured they could just do it this way. And I felt like if I taught them too many ways they get confused. But now in my old age I'm mellow and I teach the cheater pants method. Okay, so this is how you do it. You take your equation and you make your if-then chart, and first you say, well, if x is 0, what is y? And you take your hand or your eraser or something, because if x is 0, 0 times 2 is 0, and that term goes away and you cover it up. And then you say, well, then what's y? Well, why is y not alone? It's times 3. What's the opposite? Divided by 3, what I do to one side, I do to the other. 12 divided by 3 is 4. So I've got 1 point, I need another one. So this time I say, well, now what about if y equals 0, and I cover it up? And then I say 2x equals 12, divide by both sides by 12, and it equals 6. So if x is 0, y is 4. Oops, I want this line to be purple because I'm going to put all of these on one. 1, 2, 3, 4, put a dot. And if x is 6, 1, 2, 3, 4, 5, 6, put a dot. Connect the dots. Bob's your uncle. There you got it. Okay? So that's the cheater pants method, and that's the slope-intercept method. Okay, now what about if you have y equals 3? Then you go to y to where it equals 3, 1, 2, 3, and you put a dot. Then you say to yourself, no matter what, very firmly, x can go up or x can go down, but y equals 3. The reason why you need to speak to yourself firmly like that is because it's confusing. Why is it confusing? Because the y-axis is vertical, but the line y equals 3 is horizontal. So you have to say it to yourself firmly, no matter what. X can go up or x can go down, but y equals 3. And I threw my pen lid. Okay, so how about x equals -2? Same thing. You go on the x-axis to -2 and put a dot. Then you say to yourself very firmly, no matter what, y can go up and y can go down, but x equals -2. Why is it confusing? Because x is the horizontal axis, but the line x equals -2 is vertical. That's why you have to speak to yourself very firmly when you get to that. Okay, here's a word problem, and I don't do all the word problems because some of them are dumb, and some of them you will later learn a better way to do the problem. But there are other ones that are classic that you need to learn, and that's what we have right here. You are selling t-shirts and sweatshirts to raise money at your school. Your goal is to make $1,200. The profit on sweatshirts is $250. The profit on t-shirts is $150. I'm making X the number of sweatshirts I'm going to sell and Y the number of t-shirts I'm going to sell. You will notice that they pick different things in the book, but you're free to pick whatever you want on your word problem. What makes word problems hard is the words, it's not the math. So what do we have to get rid of? The words. So I got rid of all those words and I made just a list of facts. Just the facts, ma'am. So then I made sort of an equation. I said my goal is going to be equal to my profit on my sweatshirts times the number of sweatshirts plus the profit on the t-shirts times my number of t-shirts. Then I sang substitute, and I put in for the goal 1,200, for the profit on the sweatshirt 250, the profit on the t-shirt 150, and there's my equation. And then they wanted us to graph it. Well, this is in standard, so I used cheater pants, and I said that if x is 0, then y is 1,200 divided by 1.5, which is 800, and I'm going to put a dot there. Then I go the other way and say, well, if y is 0, then x is 1,200 divided by 2.5, and that is 480, and I put a dot, and I draw a line. So if I sell all t-shirts, I'm going to need to sell 800. If I sell all sweatshirts, if I sell t-shirts, I'm saying that backwards, 0 t-shirts, all sweatshirts. Anyway, look at the problem in your book, make sure it makes sense. Our graphs look the same. Oh, and it's 850. I didn't write down the right number. But anyway, this is how you do problems like this. This is a classic problem. There's not an infinite number of word problems out there. There are just certain ones, and this is one of them. We love this problem. We like to join video rental clubs. We like to buy a bunch of watermelons, and we like to leave one city on a plane and another one in a plane, and we want to know when we're going to meet in the air and crash. So anyway, learn your word problems that are the classic ones. This is one. Study it in your book. It's all easy. We're still reviewing Algebra 1, so if you need to, go back and watch some Algebra 1 videos. They're fascinating. Math is great.